So today we will discuss about the micro actuation and micro manipulation. So as far as micro actuation is concerned, so we have discussed a lot about the actuators. So there are wide varieties of actuators are available. However, on a micron level, smart material based actuators has its own potential applications towards micro robotic related development or micro robotic related design. So in this particular module we will discuss about three important topics. One is about a magnetic based micro actuation, how these magnetic based micro actuations are being incorporated for an micro manipulation in a micro robotic system. Let us see some case studies and some demonstrations by these magnetic micro robotic systems, and then magnetic actuated micro robotic systems. Then we will be discussing about piezoelectric as a micro actuator for micro robotic systems, and we will also discuss about this electrostatic characteristics as one of the key factor for micro actuation for micro robotic systems. Now first let us talk about this electromagnetic actuator. So as far as magnets are concerned, so most of us are aware about the overall fundamentals of the magnet. Now with reference to electromagnetic perspective point of view, on a robotic applications, so we have observed a solenoid and a relay are efficiently used for different robotic related applications. So if we try to talk about a solenoid, I think most of you might be aware about it. So solenoid has a electromagnetic coil and it is used for kind of a direction related applications. So basically it's a kind of a macro level actuator which is being incorporated. Relay, in most of the time it acts as a switch. So these electromagnetically driven micro actuators have a significance as manufacturers are improving the three-dimensional production methods of variety of materials. However, while electromagnetic actuators, the electrical energy is transformed into a mechanical energy like forces or torques. So the classical example of such kind of actuators includes, of course, relays, solenoid, motors, etc. So they can produce linear and rotational motion, which are suitable for many microsystem tasks. So to miniature these electromagnetic actuators, drastically the properties of the magnetic materials must be improved and the new manufacturing methods for micro winding must be developed. So these are some of the key challenges with reference to an electromagnetic actuator and the overall fundamentals of an electromagnetic actuator. So as far as an application of an electromagnetic actuator is concerned, so it is used in contactors, it is used in circuit breakers and relays to control electric motors and circuits. It is also used in switch gears and relays for electric power transmission and distribution. It is used as a head positioner in computer disk drives, in loudspeakers. So it is used in fuel injectors in engines, automobiles, trucks and locomotives. So these electro-hydraulic valves in airplanes, tractors, robots and automobiles and other mobiles are being efficiently used. And there is like in the case of biomedical prosthetic devices also, for artificial limb, heart and ear and other organs, such kind of electromagnetic actuators are being efficiently used. Now when we try to look into the fundamental of this electromagnetic actuator, so we need to understand the overall functionality or overall the classification of these magnetic materials for its application towards micro actuators. So if with reference to micro actuator perspective point of view, so we have the diamagnetism, the ferromagnetism, the antiferromagnetism, the paramagnetism and the ferrimagnetism. Now these magnetic susceptibility, which is termed as Xm, is defined through the relationship among the magnetic induction B and the magnetic field H. So the magnetization M is B equals mu naught plus Xm H, mu naught plus H plus M and mu naught is 1 plus XR H equals mu H. So Xm is the magnetic susceptibility, mu naught is the permeability of vacuum, mu is the permeability of the material, XR is considered to be the XM minus mu naught, which is a kind of a relative magnetic field susceptibility which exists. Now, when we try to talk about the type of magnetism which is being employed for micro robotic perspective point of view, so we have the diamagnetism which is there, which is a kind of a weak form of magnetism where materials are repelled by an external magnetic field. So, it arises due to the induced magnetic field opposing the applied field as explained by the standard Lorentz law. So, all electron in a diamagnetic material are paired. So, like for instance, so atom this is the shows of this shows an atom which has no magnetic moment, and XR is in the range of minus 10 power minus 6 to 10 power minus 5. Now, the main advantage of using such kind of dimagnetism for a micro robotic application is it works without requiring an unpaired electron, and a universal property of all materials to certain extent, and enables a contactless manipulation in the case of a micro actuator. However, limitation perspective point of view, it is extremely weak and effect compared to the other type of magnetism. So, it has a very less value for micro actuation. So, it is not suitable for application requiring strong magnetic response. As far as application perspective point of view, the magnetic levitation for micro actuators, precision positioning in MEMS system, biomedical devices for non-invasive manipulation are some of the key applications and examples of this diamagnetism. So, like in the case of a biomedical application, magnetism is considered to be a promising one, and these diamagnetism has a direct relevance towards biomedical related application. Now, let us talk about the paramagnetic system. So, these paramagnetic materials are weakly attracted to an external magnetic field due to unpaired electron and aligning the field. However, they lose this alignment when the field is removed. So, here the figure shows that atom has a randomly oriented magnetic moment. So, you can align it either by applying an external magnetic field, so that you can align the domains based on your requirement. So, the XR is in the range of 10 power minus 3 to 10 power minus 6 based on our requirement. As far as advantages perspective point of view, it has a linear response to external fields. It is a simple material required, basically an unpaired electron. Limitation perspective point of view, it has a weak magnetic response compared to the ferromagnetic material, and no residual magnetization after removing the field. On an application perspective point of view, microscale sensor for detecting weak magnetic fields, and actuators in low field environment for kind of a biomedical application. So, these are some of the key aspects with respect to a paramagnetic related system. Now, when we talk about ferromagnetic material exhibits a strong magnetization due to the aligned magnetic moments of unpaired electrons. They retain magnetization even after the external field is removed. So, which is a kind of a hysteresis. So, in fact, if you see this particular figure, so atoms have parallelly aligned with reference to the magnetic moment, and the XR is in the range of 1000 to 5 lakh. Now, the major advantage of this is it has a strong magnetic response, it retains magnetization, it enables a permanent magnet, high energy density of actuation. Limitation perspective point of view, it is susceptible to demagnetization at high temperatures. Hysteresis loss is in dynamic applications, and application perspective point of view, it has a potential application in micromotors and actuators in MEMS system, magnetic sensor and strong devices, magnetic tweezers for micromanipulation are some of the key applications with reference to this ferromagnetic system. So, ideally ferromagnetic systems are considered to be a standard systems which are being efficiently deployed for such kind of micro robotic application, especially these magnetic tweezers for micro manipulation are considered to be one of the key application. Now, if we try to talk about the antiferromagnetic material. So, the antiferromagnetic material, it's a kind of an adjacent atomic magnetic moments align in opposite direction, cancelling each other out and resulting in a no net magnetization. So, if we try to see the figure over here, so one set of domains are aligned in one direction and the other set of domains are aligned in other direction, result in cancellation of the overall magnetic field. So, as far as its XR is concerned, the XR is in the range of 10 power minus 6. Advantages perspective point of view, it has a high stability under external fields. It is useful for spintronic device due to minimal stray fields. And limitation perspective point of view, it has application in spintronic devices and memory systems, high frequency micro actuators for precise control. Application perspective point of view, micromotors and actuators in MEMS devices, magnetic sensors and storage devices, and again it is used for magnetic tweezers for micromanipulation related application. Now, we have the ferrimagnetic material. So, as far as this ferrimagnetic material is concerned, the material are having an opposing magnetic moment like antiferromagnets, but the moments are equal, resulting in a net magnetization. So, the common examples include a ferrite like magnetite Fe3O4 are efficiently used for this ferrimagnetic property. So, it is something like it is positive, but it is smaller than the ferromagnetic. So, if we try to observe the overall atoms and their magnetic domains, so atoms have mixed parallel and antiparallel aligned magnetic moments. As far as advantage perspective point of view, it has a high resistivity and reduced eddy current loss. It is suitable for high frequency applications and it is stable under the moderate temperature. Now, with reference to limitation perspective point of view, it has a lower saturation magnetization compared to the ferromagnetic material, limited use in high power application due to flux density constraints. Application perspective point of view, these kinds of ferrimagnetic materials are efficiently used for microwave devices like isolators and circulators, magnetic core for inductors and transformers in MEMS, thermal energy storage system at a kind of a micro scale applications are some of the key applications with reference to micro robotics and MEMS perspective point of view. Now, let us see the important law which is used to govern this magnetic actuator with reference to magnetic material based actuator for the different functional applications. So, the Lorentz force actuator, which is considered to be the Lorentz force is considered to be the key thumb force or the generalized equation which is used for quantifying the magnetic based systems. So, these Lorentz force actuators generates force based on the interaction between a current carrying conductor and an external magnetic field. The force Fl is given by Fl equals L dot Lc dot B, that is I dot Lc dot B. I is current through the conductor, Lc is the effective length of the conductor and B is the magnetic field strength. So, this is the kinds of Lorentz force actuator. So, this actuator consists of a micro machined silicon structure with a diaphragm. The current carrying wire is embedded within this structure as shown over here. When the current flows through the wire in the presence of a perpendicular magnetic field, which is denoted as BB, a force is generated that deflects the diaphragm. The force generated does not depend on diaphragm deflection, unlike the electrostatic forces. The external magnetic field is assumed to be uniform across the diaphragm span and ensuring a consistent operation in this particular system. So, ideally these are some kind of generalized Lorentz force actuators which are being used. Now, let us talk about the middle ear implant hearing device where it's a kind of a micro robotic system where a kind of a magnetic based actuator is used. So, these implantable middle ear hearing device powered by a magnetic actuation mechanism. So, the device uses a coil to drive a permanent magnet attached to the suspension arm connected to the stapes board. when the current flow through the coil, it generates an electromagnetic forces that moves the magnet and simulates a vibration in the step bone. So, this is a kind of a step bone. The device is used as an implantable hearing aid for individual with a middle ear hearing loss. It provides a high fidelity sound reproduction with a wider frequency response compared to the conventional hearing aids, which offers a precise control over the vibration for improved auditory perception. As far as operation perspective point of view, it operates efficiently across a broad frequency range. Compact design is suitable for implantation without significant discomfort. So, this is a kind of a mechanism which is being deployed by considering a magnetic actuation. This is a simple system where a kind of a bulk magnet based structures are deployed. This innovative use of magnetic actuation demonstrates its potential in biomedical application where precision and compactness are critical for enhancing the human health and functionality. So, the implantable middle hearing device powered by the magnetic actuation mechanism. So, the device uses a coil to drive a permanent magnet attached to the suspension arm connected to the step bones. When the current flow through the coil, it generates an electromagnetic force that moves the magnet and stimulates the vibration in the step bone. So, the major parameters, if we try to look into it, the frequency of the system play a vital role in this, and the micro displacement also plays a vital role in this system. This is a specific magnetic micro actuator with a planar coil. So, as far as in this particular case is concerned, in this particular case, if we try to understand the overall behavior of it, so it has a spring arms. So, these springs arms are interconnected between the stages. Then there is a small permanent magnet which is available, and this is a kind of a itch region which is there. So, like if you remember in the earlier micromechanics lecture, we had discussed about a serpentile structure, and the serpentile structure is used for the movement of the mirror. So, almost this is also a kind of a structure which we call it as a spring arm structure, which is used for manipulating the permanent magnet. So, the itching involves a kind of lithography based lithography and DRI itching for creating such kind of structures. So, in this particular case, so this is a kind of a side view. So, in this side view we have the magnetic magnetic coil which is available, and then there are springs and arms which is placed in the coil, and a magnetic course is placed over here. When the current flows through the coil, it generates a magnetic field that pulls down the spring. The physical contact between the spring and the top of the coil creates an electrical connection referred to as an on portion of the relay. The small permanent magnet ensures that the spring remains latched in the on portion even when the current is turned off. So, to release the unlatch the spring, the coil is excited with the current polarity, and that generates a repelling magnetic field in this particular system. So, overall these kind of systems are efficiently used for some kind of planar coil related application or planar coil related characteristics. Okay. Now, when we try to see the overall classification, so these are some of the overviews of the magnetic based system or magnetic based actuations which are efficiently available for development of microsystem related application. So, if we closely observe in this, in all these cases, in most of the cases we have a kind of a solid magnetic particle which is available, and these solid magnetic particles are capable enough for generating such kind of like levitations or magnetic structures which are being employed over here. Now, we will discuss about the overall classification of this magnetic based actuations, how these magnetic based actuations are classified with reference to the geometry, with reference to the manufacturing process, what are the different types of micro manipulation exist with reference to the magnetic based structures, magnetic based actuators, and we will also discuss about how these magnetic actuators are efficiently used for the biomedical related applications in detail. So, we will list out some of the applications and its characteristics in the upcoming class.